This is Unit 5, Video 2, mole to particles, particles to moles, just some practice problems. So I'm just going to do a couple practice problems here, actually 4, 2 of each, just to show you conversion. Sometimes we need to know how many moles when we know the number of particles. Sometimes we need to know how many particles there are when we know the number of moles. These are simple conversions. We're going to use dimensional analysis to do this conversion. First one is going to be 2 moles of cobalt. 2 moles of cobalt. Doesn't matter what the mass of the cobalt is, because 2 moles is always going to be 2 times Avogadro's number. So we're going to use dimensional analysis. I'm going to have moles of cobalt on the top, on the bottom, atoms of cobalt on top. I want to know how many particles, how many atoms of cobalt are in 2 moles. Okay? Well, there's 6.022 times 10 to the 23 atoms of cobalt per mole. So obviously 2 significant figures here. I'm going to get 1.2 times 10 to the 24 atoms of cobalt. Basically double Avogadro's number. The next one I have is going to be 0.821. Actually, let's switch colors here. Moles of methane. Now I have a molecule. Doesn't matter. Moles are moles. So if I have 0.821 moles of methane, I'm going to have a little bit less than Avogadro's number of methane molecules. So let's set up our relationship here. Every mole of methane will contain 6.022 times 10 to the 23 molecules of methane. Plug that into the calculator, and we're going to get 4.94 times 10 to the 23 molecules of methane. Okay? So that's conversion of moles to particles. Got to be able to do this. Every mole contains 6.022 times 10 to the 23 particles. Now let's go the other way. Let's say we have the number of particles, and we want to figure out the number of moles. So the first problem we're going to do is 8.1 times 10 to the 22 atoms of titanium. So I have 8.1 times 10 to the 22 atoms of titanium. I want to figure out how many moles. Now the atoms are going to go to the bottom. Moles are going to go on top. Well, every mole is 6.022 times 10 to the 23 atoms. So I'm going to pop that in the calculator. Remember, when you use the calculator, do not do times 10 caret. Use the EE button that's on every scientific calculator. That will allow you to input the exponent. So I do 6.022 EE 23. No times 10, don't use the 10 at all. Just EE, give it the exponent. It's expecting that's a power of 10. Okay, so when I do this, I'm going to get as a result 0.13 moles of titanium. Okay, so that gives me one problem. I can tell this is a little bit less than a mole. 6.022 times 10 to the 23 is larger. Therefore, I'm expecting to get a value less than a mole. All right, go back to our black here. So our last problem, we've got 1.26 times 10 to the 25 atoms of lithium. Again, it doesn't matter what substance it is. You probably want to track that and note it, but it doesn't matter when we're talking about moles. If we have 1.26 times 10 to the 25 particles, in there is a certain number of moles, because every set of 6.022 times 10 to the 23 particles is 1 mole. Now we can see this is much larger than 6.022 times 10 to the 23, so we should get much more than 1 mole. Okay, atoms are here, atoms coming to the bottom. We've got 6.022 times 10 to the 23 atoms in 1 mole. Punch into our calculator, and we will get 20.9 moles of lithium.